Constants are variables whose values cannot be changed once they're defined. We've seen how to create our own constants. Now let's look at some constants that are provided to us by the PHP environment. These constants are built into the PHP environment, and they're often referred to as magic constants, and they're accessible by any PHP code within the application. However, the existence of certain of these magic constants is controlled by which of the PHP extensions are loaded within your server. Magic constants, unlike other variables, are case insensitive. We typically, by convention, use uppercase to denote any constant, but this is merely a convention to make the visual inspection of the code easier and identifying the constants within the code easier. Magic constants can be very useful for debugging and for logging the application execution. Here are a few useful constants: line and file. Return the file within which and the line on which the code is currently executing. If we're inside of a function, the function magic constant returns the name of that function. And likewise, if we're executing code within a class or within the method of a class, we can get that information from the magic constants as well. So again, very useful for debugging and for application logging. Well, we have seen that the PHP environment provides many tools for us as developers. Another tool provided for us within the PHP environment is the standard PHP library. And this library is full of useful, reusable code components that are shipped as part of the PHP distribution. And the great advantage of the standard PHP library, or SPL, is that it can greatly increase our productivity as developers by providing these ready-to-use, robust, and tested components that we can drop right into our applications that do useful things for us, like providing common data structures that we can use in our application to store and manipulate data, rather than having to reinvent the wheel, so to speak, in creating these common data structures. A very robust exception hierarchy is also provided in the SPL, from which we can build an extensive application error handling system. And finally, a library of iterators that we can use in our application and interfaces for iterators so that we can create our own iteration objects. An interface as a software construct is the definition of a set of functions that must be implemented by a class that uses that interface. So the interface software construct provides for standardizing the API to certain functions within an application. So we have two new keywords: interface, which identifies the software construct, and implements, which is used in conjunction with our own classes that we're creating, identifying for the PHP preprocessor that our class will be implementing or providing the functionality for the interface that's named after the keyword implements. So in this example, I've defined an interface called printable. In that interface, I've said any class that implements this interface must provide the functionality for these two functions, print and preview. So when my movie class implements the printable interface, along with any of its other functionality, it must provide the definition of a print and a preview function, so that this guarantees for anyone that wants to use a class that is printable because they have implemented the printable interface, it guarantees for that user of that class that they can call the print function or that they can call the preview function. Those functions will always be there because the syntax of the PHP language requires that those functions be defined when the interface is implemented by that class. There is no rule to define what the function must do when implemented in the class. Typically, the function implementation reflects the intuitive meaning of the function name. So why are interfaces important? Well, besides providing a standardized interface that a user of our class can depend on, the SPL makes heavy use of interfaces to ensure a consistent API for any of the classes within the SPL. One of the interfaces provided by the SPL is the countable interface. What the countable interface allows is for any user of a class that implements the countable interface, that user can depend on being able to call the count function, because that is the function that's defined in the countable interface. And the language requires that a class that implements the countable interface must provide a definition for the count function. So here in our example, we have a class movie catalog that implements the countable interface. And notice that we have a function named count. That function is defined in the countable interface. We are required to define that function within our class. Again, there is nothing that requires us to implement it in one way or another. However, intuitively, we understand that the count method returns the count of objects or the count of data within this class. And so that's what we do in defining this function. We return the count from the array within the class that holds the movies data. There are other interesting interfaces, such as the array access interface. We can implement the array access interface to make our object have the same behavior as an array. So in our example, again, we're using the movie catalog class. This class is already implementing the countable interface, but this demonstrates how we can implement multiple interfaces simply by separating their names by commas. So we're implementing the countable and the array access interfaces. And we have the count function from the countable interface defined as we've seen previously. The four methods we must define that are provided by the array access interface are offset exists, offset get, offset set, and offset unset. We must provide functionality for these functions to do something. Obviously, we're implementing array access to provide array notation for our movie catalog class. So we want to implement these functions to provide that functionality for the users of our class. And the example here shows the implementation of one of those functions. The iterator interface defines how a class can be traversed, how it can be iterated over when we're looping with that class. And what this iterator interface defines is how our class object will behave within a for each loop. Functions defined in the iterator interface, these are required in order to provide the ability for our own objects to traverse their contained data within a for each loop. There's another iterator interface called iterator aggregate that creates an external iterator for our class. So in our case, the movie catalog, which already implements countable and array access, is now also going to implement iterator aggregate interface. What this interface requires is the definition of a function getIterator. And in this case, we've defined that as returning an iterator object of type array iterator that is initialized with the array movies. So the iterator aggregate interface allows us to create an external iterator for our class. And in this case, because the data in our class is stored in an array, we choose to create a new array iterator object and initialize that object with our movies array and return that when the movie catalog object is used within a for each loop to allow iteration over the movies contained within this class. The SPL provides a large collection of iterator types. Therefore, the need to create our own iterator is diminished. Some of those iterator types we've already seen. The array iterator we just saw. There's also a directory iterator that does exactly what its name implies. It will iterate over the contents of a directory. There's the file system iterator that again will list the names of all of the files within a specified location. But let's not confuse an iterator type with an iterator interface. When we want to provide the iteration functionality for our own classes, then we implement the iterator interface. When we want to use an iterator that's already prepared for us, that's fully functional and provided for us by the PHP environment, we are using an iterator type. So with all of that, let's go look at some code.